Let me ask you something. When you think of people who changed the world, scientists, thinkers, fighters, people who did something that the rest of humanity still lives with every single day, which countries come to mind first? Go on, say them out loud. America, England, Germany, France, maybe Japan. Now let me ask you something harder. What if I told you that some of the most fundamental shifts in how this world works today trace back to Indians, and you have never heard their name? Here's the thing, India has always been this great, unbelievable kind of place. The innovative kind, the brilliant kind. Then colonization happened. The forgetting happened. But the greatness never stopped. There are so many of these stories. Today we are telling 11 of them. The internet runs on this idea. Right now this video is reaching you through glass. Actual glass strands thinner than a human hair, running under oceans, carrying light that contains every piece of digital information moving around the world. 95% of all internet traffic works this way. Someone had to figure out that was even possible. For a long time, science said light travels in straight lines. You cannot bend it. A boy from Punjab thought his teacher was wrong about that. In 1953, he proved it demonstrated for the first time that light could travel through a flexible glass fiber and deliver a perfect image at the other end. And he coined the term fiber optics, filed 120 patents, built the entire field. His name was Narinder Singh Kapany. Fortune magazine in 1999 called him one of the 7 unsung heroes of the 20th century, specifically because his work deserved a Nobel Prize, and he never got one. When the Nobel Prize in Physics was finally awarded for fiber optics in 2009, the committee gave it to Charles Kao for work he did in 1966. But here is the thing. Kapany had demonstrated image transmission through glass fibers in 1953. 13 years before Kao even entered the field. The Nobel Committee acknowledged Kapany's contributions in their own documentation. MIT recognized him as the inventor of fiber optics. The scientific community was genuinely perplexed. Many expected Kapany to at least share the prize. He did not get a single mention. And what did Kapany say about it? He was asked in an interview with India Today in 2009, the same year the Nobel went to someone else for his field. He said, "It is known that Professor Kao started work in this field many years after me. It is up to the Swedish Academy to decide. They have used whatever criteria they wanted to use. The Nobel Committee never explained why. To this day, nobody has. The man who coined the term, who built the field, who proved it was possible in the first place, watched the prize go to someone else. He passed away in 2020. India gave him the Padma Vibhushan in 2021. A year after he was gone. The internet physically exists the way it does because of this boy from Punjab. The calculation nobody believed. This story genuinely gives me chills every single time. In 1930, a 19-year-old from Madras is on a ship to England with a Cambridge scholarship. He is supposed to be resting during the voyage. Instead, he spends it at a tiny desk in his cabin, doing calculations about dying stars. And by the time the ship reaches England, he has worked out a number, a precise mathematical limit. And that number showed something science had never considered before, that stars above a certain mass do not just quietly cool down and die. Their gravity overwhelms everything. They collapse completely, into objects so dense that not even light can get out. A 19-year-old on a ship had just predicted black holes. He presents this to the Royal Astronomical Society in London in 1935. And the most famous astronomer in the world at the time, Arthur Eddington, stands up in front of everyone and publicly humiliates him, calls the calculation impossible. The whole room believes Eddington. This poor 19-year-old just gets completely dismissed. He moves to Chicago. He spends the next few decades doing work so good that 2 of his own students win Nobel Prizes before he does. He edits a major astrophysics journal for 19 years, writes 10 books. Goes on to training a generation of the best physicists in the world. And in 1983, 53 years after the ship voyage, the Nobel Committee gives him the Nobel Prize in Physics for the exact calculation that Eddington had laughed at. NASA named its most powerful X-ray telescope after him in 1999. That telescope has given us some of the most stunning images of black holes we have ever seen. His name was Subrahmanyan Chandrasekhar. That number is now called the Chandrasekhar limit. It is taught in every astrophysics course on the planet. And here is the detail I love most about this story. His uncle was C.V. Raman, who won the Nobel Prize in Physics in 1930. The exact same year the ship voyage happened. Uncle wins the Nobel, nephew predicts black holes, same family, same year. Both Indians changing physics around the same time. The boy who had nothing. The exact date of this man's birth does not exist anywhere in any record. He was born in a village so remote that nobody wrote down what day he arrived. His best estimate of his own birthday is January 9th, 1922. He did not own his first pencil until he was 6 years old. When the family needed to light the cooking fire, someone had to go to a neighbor's house and ask for a burning ember. His father was a village tax clerk. They had almost nothing. His father spent everything he had on his children's education. The boy won scholarships, left India, went to England, then Switzerland, then Canada, then MIT. And in 1968, he stood in Stockholm and received the Nobel Prize in Physiology or Medicine for cracking the genetic code, the instruction manual that tells every single living cell on Earth how to build itself. Think about what that means. Every living thing on Earth, every human, every animal, every plant, every bacterium runs on a code written in DNA. He figured out exactly how that code gets translated into the proteins that build and run every cell. That is the foundation of all modern biology, all modern medicine, all of genetics as we know it. His name was Har Gobind Khorana. Har Gobind Khorana just kept going. In 1972, his team became the first to ever chemically synthesize a functional artificial gene from scratch. He basically invented gene synthesis. Every gene therapy being developed today, every mRNA vaccine, every CRISPR edit, they are built on what he created. And his work contributed directly to PCR, the exact test that billions of people took during COVID. One against all. Indians have always been great at building things, but there is another kind of greatness, the kind that has nothing to do with a laboratory or a patent or a formula, the kind that shows up in a room where every single person expects you to stay quiet and you do not. This story has no invention in it, no discovery, but it is one of the most beautifully extraordinary things done by an Indian. And Japan, not India, Japan made sure the world would not forget it. There is a statue in Japan of an Indian man, and he remains one of the most powerful emotional bridges between India and Japan. You might not find him in textbooks, so let me tell you about him. After World War II, Japan was on its knees, defeated, occupied, broken. The victorious Allied nations assembled a tribunal in Tokyo to prosecute Japanese leaders for war crimes. 11 judges, every single one from a nation that won the war. India, still a British colony at the time, sent a judge from the Calcutta High Court. Every judge voted to convict, except one. Justice Radha Binod Pal produced a 1,235-page dissent, arguing that every Japanese leader on trial should walk free, as the very nations sitting in judgment had spent centuries massacring people across Asia and Africa. The only thing Japan had actually done differently was lose. That was the real crime being punished. He went further. He put it on record that if crimes against humanity was genuinely the standard, then America had no business sitting in that courtroom, not after dropping atomic bombs on 2 cities full of civilians. For a nation the entire world was calling evil, this dissent was a lifeline. When everyone was piling on Japan, one Indian stood up and told the most powerful nations on earth, this process is biased. This is politics dressed as justice, and I will not be part of it. Japan never forgot him. He received some of the highest honors the emperor could give. In 2007, Prime Minister Shinzo Abe came to India and traveled specifically to Calcutta to meet Justice Pal's son, to personally deliver the gratitude of a nation decades after the man was gone. When Prime Minister Modi visited Japan in 2014, paying respects at Justice Pal's memorial was one of his very first acts. 30 years ahead of the law. In 1892, one of the most prestigious universities in the world had a rule. Women could study, women could sit in classrooms, women could prove themselves, but they could not receive degrees. Cornelia Sorabji did something Oxford was not ready for. At a time when women could study but still could not receive degrees like men, This woman from Nashik became the first woman to study law at Oxford. She sat the Bachelor of Civil Law exam, passed it, and still could not be fully recognized by the system she had just beaten. So she returned to India and did the work anyway. For years, she fought for Purdhanation, women living in seclusion who could not appear in court, speak freely to male lawyers, or protect their property and inheritance rights. The law had no proper place for them, and it had no proper place for her either. But Cornelia Sorabji became that bridge. She advised them, represented their interests, and helped women reach a legal system that had been built without them in mind. Decades later, when the law finally opened its doors to women, she became one of the first women barristers in England and is widely remembered as the first woman to practice law in both India and Britain. The world was not ready for Cornelia Sorabji, but she showed up anyway. The vision that outlived the man. In the early 1960s, a physicist walked into the Indian government office with an argument that must have sounded almost absurd. India had been independent for barely 15 years. Millions were still struggling. Infrastructure was limited. Telephone lines did not reach most of the country. And this man was saying, India needs a space program. He was Vikram Sarabhai, and he was not asking for rockets because they looked impressive. He was not trying to beat America or compete with the Soviet Union. His argument was far more practical. India was a massive country. Farmers needed weather forecasts. Villages needed communication. Disasters needed to be monitored. Crops, floods, droughts, and remote regions needed to be seen at a scale no ground system could manage. For a country like India, space was not a luxury. It was infrastructure. The government believed him. Soon, India's space journey began in one of the most unlikely places imaginable, a small church in Thumba, Kerala, near Earth's magnetic equator. St. Mary Magdalene Church became part of India's first rocket launching station. The local community moved, the church buildings were repurposed, and India's space program began with almost nothing. Rocket parts were carried on bicycles. Equipment moved by bullock carts. Scientists worked from church rooms. From that simplicity came one of the most respected space agencies in the world. Sarabhai did not live to see the full result. He died in 1971 at just 52 years old. He never saw India launch its own satellite into orbit. He never saw ISRO become a global name. But on August 23, 2023, Chandrayaan-3 landed near the moon's south pole, making India the first country in history to reach that region successfully. Vikram Sarabhai gave India its space dream. He never lived to see it fly. But the institution he built carried India all the way to the moon. 200 rupees in a window. On the morning of February 28, 1928, a physicist in Calcutta was doing something he had done hundreds of times before, shining light through a transparent material and watching what happened. What he noticed that morning and measured precisely and wrote down turned out to be one of the most important scientific discoveries of the 20th century. When light hits a molecule and bounces back, almost all of it returns at exactly the same frequency it arrived at. Same color in, same color out. But he noticed something nobody had properly documented before. A tiny fraction less than 1 in a million photons changes frequency when it scatters. And the size of that change is unique to that specific molecule. Every substance on Earth leaves a different fingerprint in scattered light. You can identify anything without touching it, without opening it, without destroying it, just by shining light on it and reading what comes back. He made this discovery with equipment worth just 200 rupees. His light source was winter sunlight coming through a window. Within 2 years, he received the Nobel Prize in Physics, the first Asian to win the Nobel in any science. February 28th is now National Science Day in India. Today, this is called Raman spectroscopy, and it is everywhere. Pharmaceutical companies use it to verify a drug is genuine without opening the bottle. Doctors use it to detect cancer cells. Airport security uses it to scan for explosives without touching the bag. Archaeologists use it to analyze artifacts thousands of years old without damaging them. The James Webb Space Telescope uses a version of it to read the chemical composition of planets in other solar systems. All of that from a winter morning in Calcutta, sunlight through a window, and 200 rupees. His name was C.V. Raman, and his nephew's same family was Subrahmanyan Chandrasekhar, the physicist who predicted black holes on a ship. Raman won the Nobel in 1930. Chandrasekhar made the black hole calculation in 1930. Same family, same year. I genuinely cannot get over this. The email his boss never read. This one has the most unlikely origin story of all the stories. In 1996, two engineers working at the same company in Silicon Valley had a business idea they wanted to discuss over email. The problem was simple. Their employer's IT system could read every email they sent from their work accounts. They needed to communicate without their boss seeing it. One of them had an idea. What if email did not live on a company server? What if it lived in a browser instead so that anyone could access it from any device, anywhere, without it being tied to their employer system or a specific machine? What if your email actually belonged to you? In 1996, this idea did not exist. Email was a desktop program connected to a corporate server. It lived on one machine, tied to one institution. Browser-based email, the kind you open from anywhere on any device, was completely new. They built it. They launched it on July 4, 1996, American Independence Day. The Indian co-founder chose the date deliberately. His name was Sabir Bhatia. Within 18 months, 12 million users. Microsoft bought it in December 1997 for $400 million, the largest internet acquisition in history at that point. It eventually became Outlook, which hundreds of millions of people use as their primary email today. He grew up in Chandigarh and Bangalore and came to Stanford on a merit scholarship. He became one of the first major Indian-origin tech entrepreneurs in Silicon Valley years before Indian founders running the world's largest tech companies became something anyone took for granted. Every time you check email on a device that is not the one you first registered with, every time email is something you carry, rather than something tied to a machine that is Bhatia's architecture, built because he did not want his boss reading his messages. The man Einstein listened to. There is an Indian name hidden inside the language of the universe. Boson, you have heard of the Higgs boson. You have heard of particles. You have heard of quantum physics. But most people never stop to ask why an entire class of particles is called bosons. The answer is an Indian physicist from Bengal. His name was Satyendra Nath Bose. In 1924, Bose was teaching physics in Dhaka. He was working on a problem involving light particles, photons, and he realized something strange. The way scientists were counting particles was wrong, so he wrote a paper explaining a completely new way to count particles at the quantum level. He sent it to a scientific journal. They rejected it. So Bose did something extraordinary. He sent the paper directly to Albert Einstein. Imagine that for a second. And Einstein reads it. Not only does Einstein read it, he immediately understands that Bose has found something important. Einstein translates the paper into German himself and gets it published. But the man himself remained far less famous than the discovery deserved. Satyendra Nath Bose did not just contribute to physics. He changed the way science understands reality at its smallest scale. An Indian mind from Bengal wrote a paper so important that Einstein himself made sure the world saw it. And today, every time a physicist says the word boson, the universe quietly says his name. The coconut farmer's daughter. She grew up in Alappuzha, Kerala, near the Thumba Equatorial Rocket Launching Station, the same site where India's space program had started with a church and a bicycle. As a girl, she could see rocket tests from near her home. That proximity never left her. Her father suffered a paralytic stroke when she was 13, the sole earning member of the family, suddenly bedridden. Her mother raised 6 children alone, insisting through all of it that every one of them would be educated and free to pursue whatever they chose. Tessie scored 100% in mathematics in class 11 and 12. She funded her engineering degree at Government Engineering College, Thrissur, with a 100 rupees per month loan from the State Bank of India. After graduating, she also sat the UPSC examination, the path to becoming an IAS officer. But her DRDO interview came through first. They asked her to join immediately. She chose the missiles. When she walked into DRDO in 1988, there were only 5 women in the entire organization. She did not spend time on that. She worked under Dr. APJ Abdul Kalam, who placed her in the Agni missile program. She became Associate Project Director for Agni 3, then Project Director for Agni 4. the first woman scientist in India to head a missile project. Then she took on the Agni 5. A missile is not powerful because it flies fast. It is powerful because it reaches exactly where it is meant to reach. She worked on the guidance architecture inside every Agni missile India has built and solved one of the hardest problems in missile engineering. The re-entry vehicle, which must survive 3,000 degrees Celsius as it comes back through the atmosphere and still hit its target. On April 19, 2012, the Agni 5 was successfully test-fired under her leadership. Range, over 5,000 kilometers. Nuclear-capable, intercontinental class. The missile that means every adversary on Earth has to calculate differently before making a decision about India. In 2018, she became Director General of Aeronautical Systems at DRDO. The media calls her the Missile Woman of India. They also call her Agniputri, Daughter of Fire. Her name is Dr. Tessie Thomas, named after Mother Teresa. Raised on a 100 rupees bank loan, chose missiles when the IAS was also on the table, and built the weapons that tell the world exactly what India is capable of. Different people, completely different stories, different centuries, different fields, but look at the thread running through all of them. Just as Powell stood alone in a room filled with the most powerful nations on Earth and chose principle over approval. Narinder Singh Kapany was told his understanding of light was wrong. He spent his life expanding what the world believed light could do. Subrahmanyan Chandrasekhar was dismissed by the greatest astronomers of his time, but history eventually proved his mathematics right. Har Gobind Khorana began life with almost nothing and went on to help humanity understand the code of life itself. Cornelia Sarabhai entered a legal world that had no place for women and still spent decades serving those whom the system had ignored. Vikram Sarabhai convinced a young, struggling nation that space was not a luxury, but a tool for development, and built the institution that would one day reach the moon. C.V. Raman used sunlight, modest equipment, and extraordinary curiosity to change science forever. Satyendra Nath Bose wrote a paper so important that Einstein himself made sure the world saw it. And today, an entire class of particles, the bosons, carries his name. Sabir Bhatia helped make communication free from one machine, one office, and one institution. And Dr. Tessie Thomas entered a field where no template existed, then became one for generations after her. Different lives, different fields, different struggles, but the same quiet truth runs through all of them. They did not wait for the world to be ready. They moved first, and the world caught up later. And every single one of them changed something the whole world still lives with today. These stories are not just about individual brilliance. They are about a civilization that kept producing builders, thinkers, scientists, lawyers, reformers, engineers, founders, and fighters, even when the world was not looking carefully enough to notice. And when you look at all these stories together, something becomes impossible to ignore. India has always produced people like this, not occasionally, not accidentally, not only in one generation, one field, or one lucky moment. Again and again, across centuries, across disciplines, across impossible rooms and impossible odds, Indians have entered spaces where the world did not expect them to belong, and then changed the rules of those spaces forever. Different names, different centuries, different battles, but the same pattern. They did not wait for permission. They did not wait for perfect conditions. They did not wait for the world to become fair, welcoming, or ready. They showed up first, and the world adjusted later. That is the part worth remembering. Few of these names were allowed to fade, not because they did less, but because for a very long time, the story of Indian achievement was often told from outside India, through someone else's lens, someone else's priorities, someone else's idea of what mattered. But that changes when we tell these stories with real facts, not with exaggeration, but by looking at them honestly, deeply, and with the respect they earned. People who face rejection, doubt, silence, delay, and systems that were not built for them and still did the work. Some of them received recognition too late. Some were celebrated only after the world had already benefited from their ideas. Some are still not known widely enough, but every one of them left the world different from how they found it. And that is the highest form of impact. So if you watch till here, genuinely, thank you. Thank you for giving time, not as blind praise, but as a serious attempt to understand what this civilization has given the world and what it is still capable of giving. If this video moved you even a little, share it with someone who should know these names. A person who has never been told how much India has shaped the modern world. Someone who feels disconnected from this country's story. Someone who deserves to feel proud, not because they were told to, but because the facts gave them a reason. And if you want more stories like these, stay with us, because there are many more. More Indians who changed science, more Indians who shaped technology, more Indians who moved law, medicine, space, defense, business, philosophy, and human courage forward. This story is much bigger. We have only just opened the first page,